and which acceleration and the rate of change of object 1 and the rate of change of v2 is acceleration of the object 2. And as you can see, this implies a1 equals to minus a2, and we have got the same equation that we guessed as the constraint equation. God, we made quite a meal of this, but I think that this formal procedure that we have written here will help us handle more difficult problems. Okay, so it was definitely, in my opinion, worth all the trouble. So I'll just try to tell you why we were so careful in this problem, because in general, in the first chapter on Newton's laws, I repeat, the main ideas that you are going to use are the free body diagrams, which you will master very fast. It's a fast learning curve. Second is writing the Newton's laws equations, Newton's equations, which again is going to be a fast learning curve. And the third part, which is a requirement of the solution of the problem, is often the geometric constraint. And you must be realizing that there will be problems where this constraint is going to be the difficult part. So we're going to now, in the next sessions, solve problems which primarily will test us in the geometric constraint, and therefore we are stressing and putting so much effort onto this. But this should not bother you too much. Just because you're unable to solve problems where you get beaten by the geometric constraint, you should not reach the conclusion that you're bad in physics. Really, the wonderful physics is here. This is where the physics is, and if you're doing well in this part, you should be very happy. But with a little bit of practice, you're also going to crack the geometric constraint, and it's a matter of solving problems, and there are ample number of problems in this beautiful textbook that will master